and welcome to this video by Schneider Electric, where we will show you how to move from reactive to proactive maintenance. We will be making use of the Schneider Electric EcoStruxure. Here we can see that this architecture combines the connected products into the edge control all the way up to the apps and analytics and services. We will now demonstrate proactive maintenance for valves, using at the bottom layer smart valve positioners, the connected products. These are connected to the edge where we will be using Field Device Expert to diagnose the valve. And in the apps and analytical layer, Maintenance Advisor will give us the device alerts. So from top to bottom, we will get a device alert that there is friction in the valve. Then we can go to Field Device Expert to diagnose the cause of this friction. These causes of the failure modes can be, for instance, air condition, the tuning of the valve, or mechanical issues, with the end effect of possible unsafe operations. We will demonstrate proactive maintenance using this setup. At the top, you will find a smart valve positioner. This is the Schneider Electric SRD991, which is mounted on top of a spring to close actuator, which actuates a ball valve. First, let's have a look in Maintenance Advisor. Here we can see that there are no outstanding conditions for this valve. In this screen, we can actually see how we can operate the valve. At the top faceplate, we can open the valve from between 0 and 100%. At the bottom faceplate, we can then see the feedback position of the valve. We are now going to open the valve by changing the valve set point to 75%. If you look to the in-picture video of the valve, you can see the ball valve opening. If we now look at the valve feedback signal, we can see that the valve position is near the 75% as expected. Logically, this didn't create any conditions in Maintenance Advisor. We will now close the valve again, so 0%, because we are going to create additional friction. We will do this by tightening this bolt against the valve stem. Well, let me show you how. And now I'm grabbing some tools to make it really nice and tight, so we can see the additional friction load on the valve movement. The valve is now ready to go. Let's open the valve and repeat our action by changing the set point to 75%. If we now look closely to the valve, we can see that the ball is not open at 75%. And if we look to the valve feedback position, it's only at 48%. If we now look at Maintenance Advisor, we can see that we actually got an alarm on this valve. It's saying that there's a deviation between the set point and the actual position of the valve. When we go into the detail screen of this valve, we can get more information. For instance, asset information. Here we can see that we are looking at a SRD991. Secondly, we will get a recommended action. Here it's telling us to go to FDE, Field Device Expert, check the input pressure, or go to the online diagnostics and check the load factor, or the online friction. And if there's friction, go to the valve and solve it. As recommended in Maintenance Advisor, we should look into Field Device Expert. We knew that we should look at this specific tag. When we open Field Device Expert, we can go online. As soon as we are online, we immediately get a first impression on the state of the valve. But as mentioned in the recommended action, we should look at the air supply to see if it's in a good state. The air supply is okay, so this is not the cause of the control deviation. The yellow color indicates that there is a off specification, which is logical because we have seen that there is a control deviation. As mentioned, if it's not the air supply, we should look at friction indication. I have now opened the tool Online Friction. And in the online friction, we can see two things, red dots and a blue line. The blue line is the spring characteristics. It's defined during the auto start. It tells us the pressure required for 100% opening of the valve and 0% opening and anything in between. These red markers are live values. It's the pressure at the current position. As we can see on the left, the current position is 65%, which is the same as we can see on the horizontal axis. However, it's using 5 bars to get to 65%, where we would expect something like 2.5 bars. So this online friction is an ideal tool to see the difference between the theoretical pressure and the actual pressure. And this is then a clear indication that there's either an obstruction in the valve or there's a heavy friction load. I have now closed the valve because I'm going to resolve the friction. Grabbing my tools and relieving the bolt from the stem to relieve the friction. The valve again has free movement. Let's repeat our exercise. Let's open the valve at 75% as we did earlier. Looking at the video of the valve, we can see it now opened. If we now look at the feedback signal in the valve position, we can see that it is gradually moving towards this 75%. In that way, a typical behavior that you expect from a healthy valve. We can now use the online friction tool again to verify that the valve is in a healthy state. And as you can see, the red markers are where they should be, next to the blue line. And there you have it. We have done proactive maintenance on a valve. We had the failure mode friction. We found the cause of the failure mode, which was mechanical, and we prevented unsafe operations.